Hey, this is Mr. Meiosis. Welcome to my video. Um, we are talking about finding the sum of an infinite geometric series. So, an infinite sum here. Well, I kind of teased this a little bit in class about how do we take the sum of an infinite series. Now, an infinite series, if you remember me talking about it, it's a series that goes on forever. Has no last term. It just keeps going and going and going. And you see, if we try to add these numbers up, right? 3 plus 6 is 9, plus 12 is 21, plus 24 is 45, and so on. It's going to get bigger and bigger and bigger and bigger. And this number, if we keep adding them up, it's just going to add up to a big number, right? But if we look at this geometric series here, where we're dividing each time by 2, right? Divide by 2, divide by 2. We add these two up together here, we get 22, right? We add 22 to 4, we get 28. We add that to 2, we get 30. We add it to 1, we get 31. We add it to a half, we get 31 and a half. We add that to 1/4, we get 31 and what's that? 1, 2, 4, 3/8, or 3/4, right? 3/4. We add it again. What do you notice about these numbers? 22, 28, 30, 31, 31, 31, 31, right? And now we're just gonna end up adding fractions and fractions and more fractions and more fractions and more fractions and more fractions, and we're just gonna keep adding for an infinite amount of times. Guess what, guys? This is just kind of mind blowing to me, and I've been teaching math for years. It's just fascinating that this infinite geometric series is going to add up to a single number. All right, a single number. Can you believe that? It's even hard for me to believe. In fact, this number is going to be 32. Yeah, this series right here adds up to 32. That's just totally mind-blowing to me that we can add up an infinite series. So let's see how we do that. There's actually a pretty nifty, easy formula for that. So here's the formula. S is the sum of an infinite geometric series. A sub 1 over 1 minus r. That's it. That's all you got to do is take the first term and divide it by 1 minus r. Can you believe that? In fact, this really only works, though, in a few cases. And it only works if our common ratio, if the absolute value of our common ratio is less than 1. Basically, what I mean by that is that r needs to be between -1 and +1. If it is, then it's going to work. If it's not going to work. We call that diverging, okay? So if r is greater than 1, basically saying r is bigger than 1 or r is less than -1, then the series diverges, okay? That's what we would say. It diverges. Let's take a look at some examples. All right. So 1/4 plus 1/6 plus 2/18. The first thing we got to do, folks, is we got to find out what r is. Because if the r isn't going to work, then what's the point, right? So the way we figure out what r is we take the second term divided by the first term. So 1/6 over 1/4. And yes, you do have to deal with fractions. All right, so 1/6, and I know I can hear some of you going, oh man, Mr. Meiosis, fractions. Sorry, we got to deal with fractions. All right, so 1/6 times 4 over 1, because we're dividing by a fraction, right? Dividing by a fraction, we multiply by the reciprocal. It's going to give me 2/3. Okay. So my r is 2/3. That 2/3 is definitely less than 1. It's between 1 and -1. So we can find the sum. So the second step we're going to do is find the sum. We're going to use that formula. A sub 1, which is 1/4, over 1 minus r, 2/3. All right, so that's going to give us 1/4 over 1/3, right? Because we find a common denominator, 3 over 3. And then we're going to get 1/4 times 3 over 1, which is 3/4. So this, guys, this infinite series adds up to 3/4. Amazing! Wow. Next one. Let's look at this one. Well, already, guys, already I can see this is getting bigger and bigger and bigger and bigger. The numbers are getting bigger. They're not going to 0. The fractions are getting smaller fractions to 0. So I already know that I'm not going to be able to do this, and this one diverges. All right, just to make sure, I'm going to figure out what r is. Okay, r is going to be 4 over -4/3. which is 4 times negative 3/4, which is negative 3. And that, of course, doesn't work, so this diverges. I want you to try one out. Try this one out here. Practice. Did you get 2? Hope you did. That's the answer. All right. One last example, folks. It's that easy. Really, it is. A sub 1 over 1 minus r, guys. It's that easy. All right? So in this one, we've got a sigma notation. So I'm going to plug 1 in right here for n. I'm going to get 5 times 1/2 to the 1 minus 1, which is 5 times 1/2 to the 0 power. And anything to the 0 power is 1. So my a sub 1 is 5. Well, what is r? Guess what? R is always the thing that's inside the parentheses raised to the n. So r in this case is 1/2. So we're going to plug in our formula, a sub 1 over 1 minus r, which was 1/2. 5 over 1/2 is 5 times 2 over 1. Remember, divide by a fraction. We multiply by the reciprocal. And our sum is 10. That's it. Amazing. You can add an infinite series. Can you believe it? I just did it. Done. See you guys later.